Hi, good morning, and welcome to the ZP Developer Zone. So we do this webinar every Thursday at 8 a.m. London time, and it's really just a roundup from the news from ZP for this week. So what I will do now is just jump straight into it. We put this slide up. Don't forget we have our ZP Academy. This is where you can find free academic and training information. The webinar, this is the webinar. We do it every Thursday at 8 a.m. London time. Collaborations, these are definitely happening. There's a lot of UK focus at the moment in terms of academic collaborations, and we do offer jobs. For example, we are actually recruiting at USN at the moment. We do have our ZP Developer Zone website, and we do have our workshops. A lot of the questions actually this week are naturally answered in our workshops. So we have had a workshop in Coventry just this week. And we do have a workshop in Horton, which is in Norway, and we do have a workshop in Coventry again in May. So there are plenty of workshops. If you see a link at any point in this video, we will have uploaded this video to YouTube, and you'll find the links underneath the YouTube video there as well. I'll go a little bit quicker. So questions this week: new form factors for sensors. I will explain that question, but that's something that we've answered this week. We do have some more information around chemiresistors, so I will discuss that. Detection of chloride, we will talk about that. Detection of calcium, that will be mentioned. Also, just a couple of, I want to call them miscellaneous really, but just talking about bilirubin and paracetamol detection, and also testing of ginger, which is our food sense. So let me go a little bit faster through this. So question number one really was, we do have these sensors. They're in a very specific kind of form factor. Again, if you see a link, then I will have linked to it. This one is particularly the calcium sensor. So we do have these sensors. They're kind of printed 2D structures, and this calcium sensor, it works really well. Now the question that is can we put them into different form factors? Because we have our sort of sensor in a very kind of particular, I call it form factor, but somebody wants them in a sort of more of a sort of flow cell type configuration, and the answer is we can shift our sensors into a different configuration, but we will need to do an engineering project when doing that. So I know that our sensors are very distinct in the way they look and feel, but if people want those formulations in different manners, let's say, then we can be part of that. And I've linked to, when I look at this image, I see that there's a potassium, a sodium, a calcium, a pH, a chloride, and this is just the reference electrode. And potassium, sodium, calcium, pH, and chloride, so I've just linked to them here as well. So again, if you see a link in this presentation of this webinar, then I will have also linked to it underneath the video as well. Question number two is about chemiresistors. So I'll put a link here because we do have something called the hypervalue carbon electrode. I have linked to it here. And I've done previous videos around this, that people are very, you can make things like gas sensors using chemiresistors. So you have two electrodes, you have often a solid electrolyte between these chemiresistors, between these electrodes I should say, and you measure the resistance between them. People spend a lot of effort designing electrodes or doing interdigitated electrodes, for example. I really think these are all unnecessary, and actually you can use much lower cost platforms, and obviously I would be a strong proponent of our solid screen printed electrodes. And I've talked in previous videos about how you can actually use, because by standard we tend to use 3 electrodes, let's say, printed on one of these screen printed electrodes. When you're making a chemiresistance measurement, you can do this in what's called a 2 and a 4 probe configuration. So the 2 probe configuration, you can definitely do it on our screen printed electrodes, and I have, either last week or the week before, did do quite a big video on the use of our screen printed electrodes in chemiresistors. But it's probably just worth saying that people make a big point of doing interdigitated electrodes. Really don't think it's necessary. They are a very expensive way of doing it, and you can just do it on a screen printed electrode as well. And in fact, I did advise somebody on this. So this is their kind of baseline. They're doing a detection of a gas. This is their baseline here. then the gas came in, and they had a change in signal, and then I think this is the gas coming off again. So you can kind of see this distinct profile due to the gas. That's on chemiresistors. Detecting chlorides. This is kind of an interesting one where somebody is cooling something that may be otherwise embedded in seawater. Seawater is obviously full of chlorides, and so the question is if I have a leak and chloride is getting into my circulating fluid, will I be able to detect the chloride? Obviously, we do a whole range of sensors, and one of the sensors we do is a chloride sensor, so there's no issue there. Again, I've linked to the particular sensor that we would use in this application. If you see a link, then I will have linked to it already underneath the video, and I hope that is useful to people. Question number 4 is about continuous calcium monitoring. I had thrown this data up just a few slides ago, but it's just so nice, so I wanted to do it again because this is calcium data showing a really nice response to calcium. It's just going off on one a little bit here, but we're going from 0, 0.1, 110, and it's really nice because calcium sensors from us are an example of ion selective electrodes, ISEs, and it's just nice that we do a 10-fold increase in the concentration and you get a doubling in the signal, and this is due to a logarithmic response, which is due to something called the Nernst equation. We are very good at putting our sensors, or at least in an MVP or a prototype manner, putting our sensors onto people. So this is an example of where we put one of our biosensors, in this case it was lactate, onto somebody, and we got some really nice response off that. And we could do the similar thing with calcium and pH, sodium, potassium, etc. So we have these biosensors, and we do have a bit of a platform for this. So if somebody spots one of the biosensors and they want to put it into a wearable format, we do have the whole stack of technologies of sensors, electronics, app. We have a cloud system called Julie. We're able to get the data up to the cloud. And then when we're doing, let's say, real development work with people, it's very useful sometimes that there are third-party devices on the market that you can use to then compare against, and it really helps you tune up your calibrations and your algorithms. And so this is just an example of something where we show the wearing of one of our sensors, and also showing that we can actually use predicative devices to help tune up our particular algorithm. Sorry, and if a link flies in, don't worry, that link is already underneath the video. Question number 5 is, this is more kind of, I should have categorized this as kind of miscellaneous. And what I mean by this is that we do have people who ask us, can you make a bilirubin sensor for jaundice in children? The quick answer is we can. There are lots of ways of detecting bilirubin. It's a very sort of aromatic heteroatom or heteroaromatic molecule. It just means it has lots of nitrogens and oxygens in it, and lots of conjugation, which just means double bonds. But these molecules are very accessible to us with our electrochemistry sensors, so we don't have a big issue with people who want to develop sensors for jaundice. Similarly for toxicity as well, I know that paracetamol is a sort of, unfortunately, it's a drug that is out there a lot in the community because you can just buy it from the pharmacist or the chemist, but it does cause toxicology, or toxicity rather, and it is something that we are quite capable of detecting on the ZP platforms. Just kind of finally, we do have something called the food sense. The food sense is I want to say super well known for being able to detect the spiciness of chilies, because we can detect capsaicin. We've also it's also got the capability of also measuring a molecule called gingerol, and gingerol is one of the molecules that causes the pungency in ginger products. And so we've been testing a whole series of gingers this week. It seems that people are very keen on sort of having these kind of suspensions, and we'll be measuring the parts per million of the active gingerol in those particular drinks, powders, shots, etc. And we have been sort of testing them out and making sure that we can measure the gingerol in there. We do it in ppm, parts per million, because that seems to be what the industry is kind of expecting in terms of units. So I've gone quicker this week because we've been doing so many long webinars that I realized, I need to be respectful of people's time. I appreciate we often launch this webinar at 8 a.m. on London times. I did go a bit early today. Lots of things going on today, so I did have to go a bit quicker, or go a bit quicker and start a bit quicker. But let me just summarize up for this week. So question number one, new form factors for sensors. We have no issues with taking the formulations that we have and putting them into new ways of presenting those sensing formulations, if I could put it that way. Chemiresistors, seems to be a lot of interest in chemiresistors at the moment. As I say, it's worth knowing that with chemiresistors you can use screen printed electrodes as the platform or the source of electrodes. People make a big thing about gold sputtered electrodes on glass. These are really not very scalable and never can be low cost ways of doing it. Detection of chloride. Chloride is one of the analytes that we do have in our arsenal, if I can put it that way. Detection of calcium. Calcium is definitely one of the analytes that we have in our arsenal, and we are able to sort of do it in a continuous manner. We do get a lot of this kind of inquiries around bilirubin and paracetamol. Bilirubin, they're both actually sources of toxicity. Bilirubin obviously is something that unfortunately happens a lot in newborn children, so sort of juvenile jaundice. Paracetamol is something that can sort of happen deliberate or accidental overdosing. But both of these molecules are detectable on our platform, and we can be involved in measuring the levels and prevention of toxicity with these two molecules. Testing of ginger. Ginger is just one of the analytes that we can test on our food sense. So again, if you see a link today, then that link will be underneath the video, and there's contact us. So if you've got any questions of ZP, don't hesitate to reach out to us. Otherwise, thank you very much.